quarks with really neat names, like up quark, down quark. I think there's a strange quark, charm quark. They have all these different names. But here's the thing. They found the same thing with the quarks. Between the quark, the thing that holds the three quarks together in a proton or a neutron is called the strong nuclear force. If that force was just turned 5% this way, stronger, or maybe 2% weaker, if it just changed either way a little bit, here's what our periodic table would look like. Just hydrogen. That would be so much easier to study. Unfortunately, none of us would be here to study it, because we just have a big gas universe, a big hot air balloon and no life. Ooh, Apollo 13. How many saw Apollo 13 or remember that movie? That is a tension-filled movie. So they're in a space capsule, the Apollo 13, and they're in space. And something goes wrong. And then a whole bunch of things goes wrong. And what this shows you is trying to make just 3 people survive for less than a week in outer space, it takes our brightest minds, and even then is unbelievably complicated and hard. One thing bursts here, another thing goes off here, and it's unbelievable what a mess it is. And that was for staying there less than a week. They didn't even have to worry about the radiation and everything else. That's just crazy. Now let's think of Earth. Earth is a capsule in space. The difference between it and Apollo 13, it has to last way longer than a week. And it has to be able to take care of billions of people and other life. And it still has to survive in space, just much longer and a much more unbelievable scale. So if it took all our best intelligence to do Apollo 13, and we could barely carry that off, is Chance capable of making this capsule? Well, if it is, somehow it got the magnetosphere just right. It created a geodynamo in the Earth. In the Earth, we have this iron and nickel in our core. It's metal. And then there's a molten outer core. The way these two interact, it causes what they call a geodynamo. Basically, it creates a huge magnetic field. So, in the center of that really pretty mess right there is Earth. There's like a bubble out in front of us of a magnetic field, and then a bubble out behind us. That's the magnetosphere. What would happen if Earth, by chance, or any planet, because other things have this too, what if they were incapable, these capsules in space, what if there was no geodynamo set up in them? Well, what would happen is, I work at a cancer center. We treat patients with radiation, photons, electrons. You've been getting treated constantly by the sun. The sun is just gushing out radiation. All these charged particles that would be tearing right through you and ripping up your DNA. Now, what the magnetosphere does is, it just shuts them all away. The only place where it doesn't totally shut them away is near our poles. And you can see there's a little area where these charged particles kind of stream in towards our poles. They don't really quite get there, but what they do is they start hitting our ionosphere and making these gorgeous lights in the sky, which are the what? Northern Lights. Yeah, that's what that's from. But if there was no magnetosphere, there'd be no Northern Lights, because that stuff would be hitting us instead, which is bad. But then again, it would have also already scraped away our entire ozone, and we would have been, all life would have been gone anyway from the radiation. So, thank God we have a magnetosphere. And I think I'm justified in saying that because I got a lot more examples. Chance is not capable of choosing among a range of options. What I'm going to do right now is I'm going to give you an atheist argument. So there was this guy who was going through all these, he was going through all the universities in North America, Canada, United States, and he was arguing that God doesn't exist, Christians totally off base, and he's supporting atheism. And he had a podcast and all that stuff. And they asked me if I'd debate him, and it was funny because on the phone they said, well, how many debates have you done? Because somebody just recommended me. So the big atheist groups, they got their speaker, and the Christian groups had to find theirs. So when they called me, they said, okay, so how have you done on your other debates? Because they were worried, you know, because this guy was good. And I said, oh, I've never debated in my life. And then I just let the phone sit silent for about 5 seconds just to make it super uncomfortable because I thought it was funny. And then I laughed a little bit. I said, don't worry about it. I said, I've seen this guy debate. He's extremely polished debater, and he's very skilled. If it was equal footing, he would destroy me. I said, but this isn't a fair fight. All the evidence is on my side. It's going to be a massacre. He's going to get exposed badly. And then that is what happened. But I gotta say, that guy brought the best arguments for atheism that I'd heard to that point. I mean, he did a great job preparing them. And here is one of the ones he brought. He didn't actually use this slide, but he should have, I think. Because this makes, see, I try to make his argument as good as it could be because why not? I don't want to cheapen their argument. All the evidence is on our side, so I don't need to cheapen their argument. You want to be honest and give their argument as strong as it sounds. And a lot of anti-Christian arguments, they sound great at first. They do sound good. I mean, when he first showed this, I was like, ooh, that sounds like a good argument. But then when you look into it, you're like, oh, wow. There's some amazing evidence. So here was the argument. So what you're looking at there was, we had this Voyager 1 space probe that was taking all these pictures of our solar system. And then it was going to go outside of our solar system and just see what it could see. And once it was about 1 billion miles away, Carl Sagan told the conductors, they said, turn it around and take a picture of Earth. So they turned the thing around and shot a picture. And you probably can't even see it. That's why it's highlighted up in the bottom corner. But it's pointing to this little pale blue dot. And they even wrote a book about it called Pale Blue Dot. That's Earth. Now, and what they were saying was, you think we're so important, we're special in this universe? Look at how little nothing we are. So some Christians, I remember it at the time, they responded by saying, well, clearly we're special because look at how the light ray is just on us. Oh, no, don't say anything. It's better than, if you don't know the answer, don't say anything. Just say you don't know the answer yet. That's just optics. The sun puts out light in all directions equally. The only reason why it looks like it's there is just because of the optics of the camera. So his argument stands. We look like we're not important. And in fact, you start comparing us to the rest of space, oh, their argument becomes strong. There's the sun. Or someone else did this picture. They did the Earth. There's a little dot right under where I said Earth. And that's next to the sun. That shows how little we are compared to the sun. And the sun is about that small compared to some of the biggest stars, like there's one, they call it Canis Majoris, that's Big Dog. That star makes the sun look puny. And the sun, now the sun, it has enough mass. That mass is one of the things that determines how much gravity it has, how much pull. The sun has so much mass, it can keep Earth and all the other planets going around it, because it has enough gravity. So wow, that's pretty massive. Well, relatively, because that's our Milky Way galaxy, and that's where our sun is, and it's so small you can't even see it. There's 200 billion other suns or stars in our Milky Way galaxy. And in the center of our Milky Way galaxy, there's a supermassive black hole that has so much mass it's able to hold 200 billion stars going around it, just like the sun holds a planet. Oh, we're looking kind of small now. His argument was sounding really good. And he didn't show this one either. He really should have. He could have made his argument so much stronger. I don't think he was aware of it because he wasn't really an astronomy guy. But if you go out at tonight's night sky, and if you go like this, and if you had the best telescopes possible, and you enlarge the space that's covered by just your little pinky finger, this is what you would see. And those aren't stars. Well, there's only a few of them in there. There are a few little stars in there. Everything else is a galaxy with 100, 200 billion other stars and planets and all that stuff. So, this universe is massively vast. And then there's just little us. It does make us look insignificant. So his thing was, you say God made this whole universe for special us. Well, if we're so special, how come we're not even a speck? And so my answer was, I said, you make a very good point. Unfortunately, that point is gutting out your whole belief that there's no God because you haven't looked at the rest of the evidence. Why is the universe so vast? Here's the answer. The universe has to be exactly as vast as it is, or we wouldn't be here. No advanced life could be. You're talking about turning a little dial? You have to get it to just the right range? Here's how precise this has to be. At the very beginning of the universe, if some, and I did the calculation myself because I didn't really trust it, so I did it myself, and they were right. If at the very beginning of the universe, by chance, just less than a dime's worth of mass was taken out, we wouldn't be here. The universe would have flung itself apart and it'd be just a bunch of hydrogen and helium and that's it. No life. No planets, no anything. If someone had flicked in just less than a dime's worth, the universe would have tried to expand it, but then it would have just right at the very beginning, right when the universe first was created, it would have tried to expand, but it would have collapsed all into itself on a bunch of super black holes, and that's it. Just a bunch of super black holes. No life. Somehow, the beginning of the universe started with the exact amount of vastness or mass. Any different, we wouldn't be here. Now, people have a hard time understanding these numbers. The numbers that the scientists give are, they said, wow, we really hit the jackpot. If the mass was different in 1 part in 10 to the 60th, that's just scientific notation.